All right, let's now speak about methods for object-oriented programming. So what's really a method? You can think about a method in the very most general sense is simply a named block of code. It's a block of code with a name, to be more precise. And it can be reusable by its name. You can call a method just by its name, rather than simply repeating every line of code in the method. So it's a really important definition over here. Again, it's a block of code that's reusable by its name. Okay, and then so this will be the conceptual model you want to have in your mind. Every method has its name over here, and also you may take as many input parameters as necessary. It could be that you simply take no input parameter. That's okay. So every parameter P1, P2, up to Pn. So these are the names. And every parameter should have a type. So type number 1, type number 2, and also up to type number n. And the type could be either primitive type or reference type. Primitive type like an integer, boolean, and also character, and also double. And reference type could be any class name, either from the Java library or from your definition. String, for example, is a reference type. And in the case of accessor, you might also have a return type. So I'm just talking about the most general case. There might be some specific cases that might be a little bit different. Okay, and inside the box over here, think about the method is like a black box from the user's point of view. So inside the curly braces, you will simply put in the body of the implementation over here. That's so there's very abstract definition over here. I'm going to give you a concrete example as well, but I will highly recommend that's kind of the model you want to have in your mind. And the header of a method consists of, so header, okay, over here. So it's a very important term here called header. So it will be return type RT, return type, and which may be void in the case of the mutator method, of course. And also the name of the method over here, and also 0 or more, right? Notice that it doesn't have to be always present. It can be just 0 parameters. You can see from P1 all the way to Pn, the parameter. And also the corresponding types for the parameter. So that'll be T1, T2, all the way to Tn over here. And also, so that's about the definition. That's about the definition for the method. What about how we use it, right? Remember, it's reusable by its name, a block of code. So a call to the method m has the form. So you're going to say m, the name of the method. You don't need to repeat every line that's inside because it's simply just hidden from the user. You'll simply just by calling its name instead. So it would be just by passing A1, A2, all the way to AN. So now there's something I'm gonna explain in just a moment, but I will just draw to your attention here. So here, A1, when you are trying to make a method call, so the A1, A2, all the way to AN, so these are called argument values. But A1 somehow is corresponding to the input P1. And A2 over here is corresponding to the input parameter P2. So we actually make a distinction. Whenever you talk about the definition for the method, we talk about parameter. But when you talk about actually calling the method with some specific input values, we call them arguments. Right? That's something I would like to emphasize, but I will try to visualize as well for you. All right, so let's now switch to iPad. That's exactly the definition I just went over. I just want to say one more thing here. So when we talk about the header of the method, right, the header, and this is when we talk about how we define a particular method. It will be basically return type. Remember Java syntax. You gotta put a return type over here, and also the name of the method. Let's not worry about public or static. It's not relevant to the discussion here. And also the name of the method. You can see return type already. And also the name of the method, and also parameter. You can have as many as you like. It can be T1 and also P1, comma T2 and also P2, all the way to Tn and also Pn, right? So you can see P1, P2, all the way to Pn. So these are the names of the parameters, and also T1, T2, all the way to Tn. So these are the types for the parameters. So that's the definition, and of course you might actually get some code inside, but this is actually hidden from the user. So whenever the user wants to use the method, they will only just call the name of the method, right? So that's about, so far the blue one is just about header, just the definition. What about the usage for the method? So when we talk about the usage for the method, you will actually, first of all, you would say the name of the method m, and then you want to pass as many input arguments as required. So that's what we call argument value over here. So now in this case, how many do we need to pass? The answer is n, because you can see we need to pass 1 for P1, 1 for P2, and also 1 for Pn, and etc. And the value we pass for P1 must be of a type compatible with T1. And the value we pass for P2 must be of type compatible with T2 as well, right? Well, I will see concrete example in just a moment. So here I'm going to say A1. So, and A1 must be of type compatible with T1, and comma A2 must be of type compatible with T2, and all the way to AN, right? That's how we actually use a method all the way to AN. And AN, of course, is of type compatible with TN. Let's now talk about the difference between parameters and arguments. So P1, P2, all the way to Pn. So we call these simply parameters. So these are when you actually define the methods, you want to use the names. On the other hand, over here we got A1, A2, and also AN. It's a particular call to the method. So we call these the arguments. Sometimes people like to simply use this part, also call them arguments, but I would say to be formally correct, it's better to say parameters when you talk about definition, and you say arguments when you try to make a particular method call, right? I'll try to stick to the right terminology myself when I mention to you from now on. All right, so that's about what you need to know about method. And for the method, we'll talk about different kinds of method in just a moment. Let me just give you one concrete example about parameters versus argument over here. Let's say we have a class called points, and then we, assuming that we already declare x and y being attribute, let's ignore that for now. So we got basically point constructor, we got double x, double y. You can see, so for the constructor, they always have the same name as the class, so we have no choice. So parameter 1, parameter 2. And here we got one parameter. So here we got two parameters, right? You can see, for example, you can think about here, it's a little bit like the P1, and this is like a P2, and this is like a T1, this is like a T2 that we spoke about previously, right? Let's see this, right? Let me just undo this. Let's just take this particular one, for example. You can see direction, and also units, and also other here, and also x, and also y. So all of these over here, and also all of these are called parameters. And when you're trying to call any of the methods over here, you have to pass arguments. For example, you can see here. Let's say once you create P1 and P2, let's say you have done that, we're going to trace, we're going to visualize this a little bit later. But let's just see for this particular example. Let's say when you say P1 that get distance from and P2, you can see here we are calling get distance from, we're calling this particular method over here. So you can think about the P2 over here is the arguments. Whereas you can see P2 over here is the arguments, whereas other over here is the parameter, right? You can see the difference over here, right? And then we're calling this particular method here. So this is about usage, and this is about definition. Similarly, let's say we also try to call the same method one more time, and then P1 over here is also just another argument, right? It's for different method call. And it's really for the same parameter. Again, it's actually also for other over here, right? You can see other may be replaced either by P2 or P1, right? When we did the tracing. All right, so that's the difference between parameters and arguments. Hopefully that's clear to you. All right, let's now go back to the slides. And we talk about the method. Let's say in the body of the method, what can you really define as a developer inside the method, the body of the method? You may declare new local variables, and once you declare local variable, the scope is going to be within that method. For example, if you let's say we are trying to define this particular method over here, and then you can see enclosed within the curly braces is the body of the method. If you declare any local variable here inside, it's going to be just within the scope of this particular method. That means inside the body for this particular method, you just cannot get access to the local variable that's in there, right? It's quite straightforward. And we can also use or change the value of attributes depending on, so in the case of accessor, you may just want to use the values for the attributes without modifying them. In the case of mutator, you may both use and change the value for the attributes, right? So that's something we'll summarize later too. And you may also use the parameters, if any. If your methods itself actually got some parameter value, typically you will want to use them. You don't normally change the parameter values. All right, this is just some example. You can see here, we just got some parameter value over here. Notice one thing here, I deliberately choose the name of the parameter that's different from the corresponding attribute value I want to change, right? That's intentional. So this is why I really do not need to use the this keyword, but the this keyword is kind of implicit. I'll speak about the this keyword a little bit later. Okay, I'll do that. And when you call a method with a context object, right? You're gonna whenever you call the let me just see this. So you can see when we call Jim.change nationality, and also we call Jonathan.change nationality, you can see we're calling the same method over here, change nationality. Okay. However, you can see here the arguments happen to be the same. The arguments are just Korean. Okay. However, the context objects is Jim and Jonathan. So that means since you are calling the same method on distinct context object, so that means the consequence might be different, right? That's something also we emphasize in the tutorial videos. Okay, so for this slide here, first of all, understand the scope for any local variables you might declare within a method, and number two, make sure you understand what the context object is. It's basically whenever you want to call a method, you want to specify what's the context objects to apply the effects for that particular method. All right. And here I just simply summarize the context object and method call abstractly. So let's say methods, you should really talk about where the methods are defined. Let's say they are defined in class C, right? For example, get weights may be defined in the class person. And then method M is simply a name block of code for being reusable, right? That's something we talk about. And also to reuse it, you want to call the method N by calling it on the objects of type C. Is really important, right? Let me just show to you. So now if you whenever you got this particular method call, you want to make sure it is valid. What does it really mean to be valid? For that to be valid, the method M over here must be declared in a class that must be declared in a class C. And now the context object over here will only be valid if object is declared to be of type C. Okay, so what I meant was this. So let's say over here, if I talk about this particular method call, let's say p1.get distance from. Why is this method call valid? It is because number one, you can see p1 is declared to be of type point. And in the point class, we do have a get distance from method. That's why calling this method over here will be valid. That's basically what I wanted to say in the slides. I just said in a more abstract way in the slides. Okay, but that's the example you can see. And also you can see this will be valid as well because you can see P1 was declared to be of type points, which does declare a move method over here, which will take character and also double. You can see character here and also double here. That's why it is valid. Okay, let's switch back here. Right, so here you can see Jim.getOlder and also Jonathan.getOlder. Calling the same method might give you different effects because the context object Jonathan versus Jim over here, they're different. Similarly, you got P1 versus P2, right? So here, for example, it will be invalid. If you call Jim.getMoveUp, it will be invalid because MoveUp is now really defined in the Jim's type, which is the person class, right? Similarly. All the objects of class C share the same definition of method N, yeah, because depending on what the context object is, you might just have different effects. Okay, just like that. So you can see each object may have distinct attribute values, so that means applying the same definition has these distinct effects. You can see here, by calling get distance from, you're basically calling the same definition that's defined over here, the same. However, the effects might be different because the context object P1 and P2, they're simply just different, right? And let me say one more thing about how you can check the validity of the method call quickly. Okay, let's now talk about this one here specifically. Let's say we try to do, let me highlight it here. Let's say we say P1 that get distance from P2. Why is this line of method call valid? Let me give you the example. Let me explain this example in detail. You can extrapolate that into the general checking yourself. Okay, let me write it down over here. So I got P1 dot get distance from and then P2. Okay, let's now, before I start analyzing, let's clarify the terms. So P2 over here is the arguments. And P1 over here is the context objects. Okay, let me spell it quite correctly. Context objects. And now, why is this valid? So there are several things we have to check. So number one, we have to make sure, number one, the method we are calling is actually declared. Is it declared in the context objects type? Okay, that's the first question to ask. So now, what's the method declared? The method being declared is get distance from. So get distance from is over here. And what about the context objects type? P1's type is actually point. So now the question is get distance from a method that's declared in the point class? The question is, the answer is yes, because it's exactly over here, right? So the first question here will be check. So that's the first check to see. And what about second one? So now arguments that we are passing to this particular method call, arguments compatible with parameter types, compatible with parameter, I would say parameter types. Okay, that's the question. Okay, let's see exactly. So now you can see the argument is only just P2. Do we also, are we only expecting one parameter for this to get distance from? Yes, indeed, just one. And what's the type? It's simply just point. Is P2 of type points? Indeed, P2 is of type points over here. All right, guys, these are the two questions you always have to ask in order to check whether a particular method call is really valid. Okay, let me recap very quickly. Number one, you want to check to see whether this particular method is actually called in a class in the type of the context objects. Okay, so P1 is of type points. Does point actually got this method declared? If the answer is yes, number one. Number two, you want to make sure the number of arguments should really match the number of parameters. Furthermore, you have to make sure every argument must have the type for the corresponding compatible with the corresponding parameter type. You can see P2 over here must be compatible with point. And you can see P2 is declared to be of type points. Okay, it's really important for you to see how to check this. All right. Finally, I'll let you go back to the slides and talk about the three kinds of methods we can have for OOP, and then we'll talk about in the next videos how to the individual of them. Okay, we'll see that. So we got first kind constructor, and then should be of the same. You know what? So these are simply just definition here. We already knew. Okay. You want to use a new keyword and also no return type, and also should be of the same name as a class, right? So that's something we have seen already. Mutator. Okay. They are only supposed to change or reassign the attribute values. They are not going to return anything. So that's why it's void return type. And also cannot be used when the value is expected. What do I mean? So here you can see gym.setWeights. Let's say the setWeights is defined as a mutator method returning void in the person class. So now, since gym.setHeights over here is not expecting to return anything, it's only to return void. So void cannot be assigned to a double. Right, so that's why it's illegal. I will have another exercise for you at the end once we talk about accessor and mutator. But you can see this is really something important for you to understand. And also for accessor, it's only supposed to use the attributes for computation and without changing them. So it's really an important design principle. Some Java developers might also choose to really change values inside the accessor. It's syntactically allowed, but it's not recommended. It will be a better practice if you really want to change the values for the attributes. You really should have declared mutator instead rather than accessor. Don't really compromise this principle just for convenience, I would suggest. And then any return type other than void. It can be integer, it can be boolean, can be reference type as well. And an explicit return statement must be there. Remember, I got a syntactic comparison between the accessor and mutator in the tutorial video. You can review that as well. All right, and then this is just one example. You can see gym.bmi. Let's say get bmi returns a double value. Let's say in that case, we can assign this particular return double value into the bmi, which is a double variable, right? On the other hand, when you're calling a mutator method returning void, you just cannot assign that to anything, right? So that's why this one is illegal. We'll see more examples later. All right, so that's about the summary about the 3 kinds of methods. We have seen all of them already in the tutorial videos, but I just want to review each one of them quickly in the next videos.